Hey kids, welcome to Objective 18. This is an advanced objective, but an important one. This is something that is part of the algebra curriculum, and I'm excited to share it with you so that you are in an advantage next year when you are learning these things again. Hopefully it'll be much easier for you then. Quick disclaimer before we get started. This won't be a perfect or exhaustive lesson. Of course, different math teachers teach things differently. This is just the way that I'll present it. And of course, if you have questions, you're very welcome to follow up with me by email or in class. So here we go. Let's jump in. So we are going to, again, multiply and divide monomials. You don't even know what a monomial is. I will show you in a few moments. And we're going to do multiplication first and then division. So here we go with multiplication. So let's say I want to multiply 2 cubed by 2 to the 4th. Well, remember that 2 cubed means 2 times 2 times 2, or we could say 8. And let's say I want to multiply that with 2 to the 4th. 2 to the 4th means 2 times 2 times 2 times 2, which would be 16. Now if you look across here, you see the same base being multiplied with itself 1, 2, 3, 4, 5, 6, 7 times. So I can write this 2 to the 7th power. Well, if I multiplied 8 times 16, I would get 128. Well, would you like to take a guess what 2 to the 7th power would be if you used a calculator? I went and grabbed a calculator, but it occurred to me how silly that was because I'm talking about a base of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. We could have done that in our heads, but to show you, I could also do 2 to the 7th, which is 128. These are equivalent. Let's do another one and see if we can find a shortcut that we can apply in the future. 6 to the 5th means 6 times itself 5 times. I did the math ahead of time to save us some time. 7,776 times 6 squared. 6 times 6 is 36. Well, if you multiply a 7th, I can't do that one in my head. But again, I did the math ahead of time. You're welcome. Okay. Here I have a whole bunch of 6's lined up. 1, 2, 3, 4, 5, 6, 7 times. 6 to the 7th power. Now, you could probably guess that if I put 6 to the 7th power into the calculator, I would get the same solution. Okay, if we study these previous examples, we can see perhaps how I can get to a solution without having to do this whole table of work in between. 3 and 4 to 7, 5 and 2 to also 7. It looks like we could just add our exponents, b plus c, because there's 5 of them, there's 2 of them. If we add that together, there are 7 of them. Adding the exponents is in essence counting up how many times that base is being multiplied with itself. So let's try a few using that rule. Feel free to try a few on your own, pause it, and then hit play again and see how accurate you are. Okay, same base of 4, 2 and 3 make 5. You could either write it like that, or you could calculate 4 to the 5th power, which is 1024. It's the same with variables, so same base as x, 9 and 3 make 12. Same base, only this time it involves a negative and it's in parentheses. 5 and 3 make 8. Now this is a special thing because this exponent of 8 goes to everything inside of the parentheses. Well, what happens if I multiply a negative by itself 8 times? Or we could also say, what happens if I multiply negative 8 with itself 8 times? Let's write it out once. We wouldn't want to do this in real life. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So here are the m's. That's the easy part. 1, 2, 3, 4, 5, 6, 7, 8. So that's m to the 8th. Now look, a negative times a negative is a positive, A negative times a negative is a positive. A negative times a negative is a positive. A negative times a negative is a positive. So this is a positive m to the 8th power, or simplified in parentheses negative m to the 8th power truly means m to the 8th power, because this is an even exponent, right? An even number of negatives cancel each other out. If this had been an odd number, then I would have had an odd result here. So for example, this is negative n to the 2 plus 3 is 5 to the 5th power. Now if I multiplied negative n with itself, I said I was only going to do this once, there's a reason for it. It's hard to do that. Here's 1, 2, 3, 4, 5 n's. Negative and negative cancel out, negative and negative cancel out, and I have this negative left. So that's why this is a negative n to the 5th. All right, here we have z. 6 and 7 make 13. But do I need those parentheses? There's nothing on the outside really to change it, so I can just simplify to z to the 13th power. What if I don't have an exponent? Well, we wouldn't write 1 to the 1st power because that's just kind of silly. But if I had to have an exponent, it would be 1, not 0, 1. And so, if 1 to the 4 plus 1 is 5. 1 to the 5th power, or 1 times itself 5 times, is just 1. Okay, so let's step this up, and now we have not just numbers with exponents, but we have monomials, a mix of coefficients and variables, and sometimes more than one variable. So this time we're going to multiply 6x cubed with 3x to the 4th power, or that means 6 times x 3 times 3 times x 4 times. And so if I multiply these two together, 6 times 3 gives me 18. And how many x's do I have? 1, 2, 3, 4, 5, 6, 7. X to the 7th power. All right, let's do another one and see if maybe we can find a shortcut in the future. So this means negative 4 times 2d's, and this means 8 times 4d's. 4 times negative 8 is negative 32. 1, 2, 3, 4, 5, 6 d's. What are we doing here? It appears that I'm multiplying the coefficients. Those are the big numbers. And then we add the exponents. Now we're not really just adding the exponents, we're counting up how many times that exponent is being multiplied with itself. So we're adding the exponents to get the answer, but truly we're multiplying the expressions. Okay, so let's try a few. And for these I'm going to zoom in because exponents are really hard to see in a video. Okay, so again, I welcome you to pause this and try on your own, and then start up again and see if you're accurate, or you can just watch. So negative 5 and 6 is negative 30. B's. 9 and 2 make 11. Let's try another. 2 times 3 is 6. Y's. Negative 3 plus 5 is 2. 6y squared. And the last one. Negative 3 times 5 is negative 15. Now we have x's. 2 and 5 make 7. And now y's. 4 minus 2 is 2. So when I have multiple variables, you just handle one at a time. It's just like a longer problem. It's not more difficult, just longer. Okay, as we go to the next page, I want you to look to see that the division is set up in the exact same format as the multiplication, so that you see that they are just the opposite of each other. Like every little part of it is just the opposite. So truly, if you took this front page of notes and crossed out multiplication, just did the opposite of what we've done, you would have the division notes if you wanted to do that. Or since you have this pretty worksheet that I made for you, we can do division that way. Okay, so let's work on some division. If I have 2 to the 4th power, that really means 2 times itself 4 times. Over 2 cubed, that means 2 times itself 3 times. Well, anything over itself is 1, right? 2 over 2 is 1, 2 over 2 is 1, and 1 times anything is itself. So changing these to 1 doesn't change the value of this. So I just have one little 2 left, or we could just say it's just 2, right? So we could say another way, 2 to the 4th over 2 cubed. What is 2 to the 4th? 2 times 2 is 4, times 2 is 8, times 2 is 16. We said 2 cubed is 8. 16 over 8 is 2. Look at this. Say hi, Mina. Oh, where are you? It's hard to get a video of you. Oh, say hi. Meow. She likes to be part of these videos. I think she secretly wants to be a YouTuber. Okay, let's try another one. See this time if you can find a shorter way to do this, because I'm lazy and I'd like a shortcut. 6 to the 5th. 1, 2, 3, 4, 5. 6 squared. 2 times. These cancel, and by cancel I mean anything over itself is 1. 1 times anything is itself, right? And I'm left with 3 6s in the numerator. So 6 to the 3rd power, or you could say 216. They mean the same thing. So if you took 6 to the 5th, which is, I did the work for you, 7,776, and divided it by 2 squared, which is 36, what do you think you would get? So, divided by 36, you would get that same 216, which we know is the same as 6 cubed. Do you see the pattern? Do you see how we went from here to here, or here to here? Well, remember I said that division is the opposite. Yes, so instead of adding, I'm going to subtract my exponents. So this would become a equals b minus c. So let's try a few of those. Oops, I just moved the whole thing. Okay, so this becomes 7 to the, what's 9 minus 6 is 3. It's always going to be top minus bottom, not the biggest exponent minus the smallest exponent. That's the biggest problem that I see kids make. If you would rather keep going and find out what 7 cubed is, you can do that. Okay, feel free, remember, to pause this and go ahead on your own, right, to see if you are correct. So 100 to the 9 minus 8 is 1, or you could just say 100. Ooh, what is my exponent up here? Is it 0? No, it's 1. So x to the 1 minus 6 is negative 5. Now that's the correct value, but it's not the right format. Remember in our previous lesson, we learned that it's best to write our exponents positively. So you would then turn it into this fraction. Okay, if ever you have your division written horizontally, this means the left number divided by the right number, so like this. You don't have to rewrite it, I just wanted to demonstrate it once. So this would be r to the 5 minus 7 is negative 2, or how would you write that? Yep, just like that. Good. Okay, let's try another one. This base has parentheses and a negative. 12 minus 5 is 7. Now, do you remember what to do with this? I have an odd exponent, so my result is going to be negative c to the 7th. If my exponent had been even, that would be positive. Okay, when you have a mix of parentheses and not, ask yourself, would it hurt anything if I add parentheses? That's the right value, and I have one of them, and now I can deal with it. 3 minus 1 is, 2. And a negative times a negative is a positive. W squared is our final answer. All right. So we can make this even more difficult. And just like our previous page, I think you can probably predict what we are going to do to find our solution. Okay, we can do 6 divided by 3, which is 2. Now the x's, 8 minus 5 is 3. And to show that, what that really means is 6 times 8 x's so these are all canceling out, right? And so this is how we get the 6x to the third over 3, and 6 over 3 is 2. Okay, let's try another one. So this is 15 and 3y's, and negative 3, 2y's. Cancel out, so I'm left with 15 over negative 3. What is that? It's negative 5. And y's. Remember that the base can be negative, or the coefficient can be negative. It's the exponent that cannot be. So this is our final answer. So if you keep in mind what we did for multiplication and also compare what we did here to the end result here, see if you can find a rule that we can follow in the future. I'm going to divide the coefficients and then subtract the exponents. So for multiplication, we multiplied the coefficients and added the exponents. For division, we divide the coefficients and subtract the exponents. We do the exact opposite. So let's zoom in and we can try a few of these. All right. So again, divide the big numbers, subtract the exponents. So 4 over 3 is 8. And y's, negative 7 minus negative 9. Let me write that out. Negative 7 minus negative 9. Well, two negatives make a positive. So really it's negative 7 plus 9, or 9 minus 7, and that is 2. So if you have a negative exponent in the denominator, be aware that instead of subtracting, you're really kind of going to be adding. Let's try another one. 6 over 2 is 3. Now the x's. 5 minus 3 is 2. Now the y's. 3 minus 6 is negative 3. Oh no. Okay, you know that that's the same as 1 over y cubed. If you would like a shortcut, keep the part that, let me circle here. This is the only part of the expression that is not in the right form. So we'll keep the good part, 3x squared, and the bad part just gets flipped to the denominator and it has a positive exponent. So that is our solution. Let's try another one. Now this one you can either work horizontally or you can draw a line underneath this and write in 4x to the 7th, y to the negative 3rd, z to the 5th, whichever you want. All right, negative 16 divided by 4 is negative 4, and now the x's. Negative 3 minus 7, negative 3 minus 7 is negative 10. Now the y's. 4 minus negative 3. 4 minus negative 3 is really 4 plus 3, 7. And z. 5 minus 5 is 0. So now we have some simplification that we need to do. First of all, anything to the power of 0 is 1. And 1 times anything is itself. This just canceled out. And so the part that we need to fix here is this x to the negative 10th. So we can keep just the same, the negative 4 y to the 7th, and bop this x to the 10th in the denominator. Like so. Okay, those are getting pretty difficult, so if I lost you there, you'll be okay. We'll get plenty of practice and we can move on just fine. Okay, well, Mia is sitting on top of my papers that I need. Hey, Brett, you're gonna have to move. Oh, gosh, I messed up the tripod. Sorry, cat. Hey, that's fine. Thank you. Oh, and now it's warm. That's gross. She just really wants to be a part of this. Okay, so I realized that there are notes on the back of this page for Park or IAR questions, and those are important, but this lesson is really long, and for just the sake of time, I'm going to just do the lesson part, and if you have questions on the Park questions, I can help you later, but I want to keep this concise so that I don't have problems uploading it. Okay, so here's one more small variation. This is powers of powers. This is when you have an exponent on an exponent. So this is literally, you would read this 8 cubed squared. So what that means is 2 groups of 8 cubed. Well, you know that 8 cubed is 8 times itself, 3 times. So all this means all this. Well, I'm repeating this 8, 1, 2, 3, 4, 5, 6 times. So this is 8 to the 6th. Or if you multiplied it out, it would be 262,144. Mental math, right? No, I did that ahead of time. Okay. Let's do another one, and perhaps you can see a shortcut that we can take when we're doing powers of powers. This means we have 4 groups of y cubed. 1, 2, 3, 4. Or y cubed means 3 groups of y's. Like so. Well, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 y's. And that's my solution. Well, how can I get from here to here, or here to here in an easier way? Right, I could just multiply my exponents. So a to the xy means a to the xy. I multiply them together. So let's try a few. And you're welcome to go ahead of me and try a few on your own. And then hit start again. M to the 5th cubed is the same as m to the 15th because 5 times 3 is 15. This would be a string of 15 m's all together. And I'm not going to write all that out because that'd take forever. Okay, now this would be 4 times 2 is 8. So negative 7 to the 8th power. Well, what is a negative to the power of 8? It's positive, so 7 to the 8th power. All right, and finally, this means 2 groups of this expression. This exponent goes to the 3, it goes to the 5, and it goes to this 3 too. So this means 3 squared. X to the 5 times 2 is 10. Y to the 3 times 2 is 6. And we could simplify that further and say 9x to the 10th, y to the 6th. All right, so when we're multiplying exponents with no parentheses, we add the exponents, but if we do a power on top of a power, that's when we multiply the exponents. Okay, let's do the last page of this. And then we'll get you going on your homework. Okay, so hopefully this is review to you. If it's not, we will be now making a reference page that you can use moving forward. Remember that product means multiplication. So if I ask you the product of 5 and 3, I'm asking you to find 5 times 3. Quotient is the opposite, it's division. One number divided by another. The quotient of 6 and 3 is 2. 6 divided by 3 is 2. Squaring a number is an exponent of 2. And cubing a number is an exponent of 3. So using that bank of vocab words, we can do some simple, very simple word problems. I wouldn't even call them word problems because there's nothing real going on here, but they're words in the sense that they're not numbers. So the product means multiplication. Let's see what we're going to multiply. 2 squared, squared is 2, exponent, and 2 to the 6th power. All right. With multiplication, we keep the same base and add the exponents, 2 to the 8th. Good. Let's do a quotient one. The quotient of 10 to the 6th, sorry, 7th. When we do quotients, the first thing listed goes to the left. Second thing listed, 10 cubed, follows. Or if you wanted to write it vertically, whatever's on the left is the numerator, whatever's on the right is the denominator. Same base, 7 minus 3 is 4. Okay. Feel free to pause and do the last two, and then hit start again to see how you do. Product is multiplication, y squared and y cubed. 2 and 3 make 5. And quotient. We're going to divide a to the 20th by a to the 10th. Now, would this be a squared, or would it be a to the 10th? It would be a to the 10th. I understand that 20 divided by 10 is 2, but remember you subtract your exponents with division. Okay. You brat cat, you're totally sitting on my stuff again. Okay. Let's look at your homework. So you have lots of questions here. I strongly suggest that you use your notes to help you. They are reflecting your homework, I suppose. So these are all multiplication. That's from the first page. Sorry. Am I zoomed in? Zoom out. These rows are division. And this is power of powers. Pop for this row. And then these are from the last page. All right. So let's do a couple just to get you going. Same base of negative w. 6 and 3 make 9. Now 9 is an odd number, so if I multiply negative w by itself 9 times, I'm going to come out with a negative w to the 9th power. And that's your final answer. Let's do a power of powers one. H to the 5th to the 10th would be h to the 5 times 10 is 50. And a division one. Same base of 3. 18 minus 12 is 6. And if you wanted to, you could multiply that out. It would be 729. I don't care which one you circle. Now remember, if you have monomials, I'm looking for one here, multiply your coefficients and then add your exponents. So negative 13 plus 29 is 16. So take it in pieces. Same with division. 32 over 4 is 8. Now y's. Negative 7 minus 9. You could write out y. Negative 7 minus negative 9. 2 negatives make a positive. 9 minus 7 is 2. There you go. And that's your challenge for practice on that. As always, if you have questions, you're always welcome to send me an email. You're never a bother to me. I'm happy to help. All right. Thanks, guys. Also, if you have questions, I'm happy to answer them in class. But until then, we'll see ya. Bye.